Dear students of 10th standard, let us see some of the very important questions from the point of view of science exam. Now, from chapter 1, I have chosen some of the important questions. First question will be like what are the different types of decomposition reactions? With examples, you need to explain these, and the examples must have the balanced chemical equations. The first question will be like, what is decomposition? The decomposition is the chemical reaction in which one substance breaks into two or more substances. The reactant will be only one, the products will be two or more. The first kind of the decomposition reaction is thermal decomposition. Thermal means the heat. The heat is used to decompose the materials in this chemical reaction. The important example is lead nitrate, PbNO3 twice, on heating gives lead oxide and nitrogen dioxide gas. Nitrogen dioxide gas is brown colored gas, and along with that oxygen is produced. Now this is a very important reaction because in a laboratory we produce the oxygen gas also using this reaction, and we can even test the acidity of the nitrogen dioxide gas. When moist blue litmus is taken near the nitrogen dioxide gas, it turns blue litmus red because it is acidic oxide. Second reaction is electrolytic decomposition. It is also called as electrolysis of water. Water breaks into hydrogen and oxygen. 2H2O gives 2H2 plus O2. It is an example of even the redox reaction. Redox means reduction and oxidation together. Every chemical reaction is a redox reaction, but you need to find which undergoes the reduction and the other one undergoes the oxidation. If the element loses the oxygen, it is the reduced element. So here hydrogen is reduced and oxygen is it is losing the hydrogen, so it is the oxidized element. Now the third type of decomposition is photolytic decomposition or photolysis. In this you can study two chemical reactions. Silver chloride in presence of sunlight gives silver and chlorine, and silver bromide if you take, it is also going to undergo photolysis and it will form silver and bromine in the same way. Now in this you can be asked some application questions like this. Name the salt of a metal which undergoes photolytic reaction. That is, the salt is silver chloride. You can also be asked as which salt cannot be kept in a transparent glass bottle, or it should be kept in a black colored bottle. So the chemical will be silver chloride or silver bromide because they undergo spontaneous photolytic reaction in presence of sunlight. To avoid the reaction, we can use the black colored bottle to avoid the entry of the light. So silver is the metal which is formed by photolytic reaction of silver chloride. And you can even be asked that which gas is released when silver chloride is kept in sunlight. The gas will be chlorine gas. Now let us move to the next tricky question, that is barium sulfate solution when added to sodium chloride, what happens? Generally when we see two salts, we will conclude that it is a double displacement reaction. But here barium sulfate being insoluble salt, it doesn't form the ions because it is insoluble in water. As it is not able to form the ions, free ions, there is no exchange of ions and there is no possibility of double displacement reaction. So nothing happens when these two chemical compounds are mixed. Now, if you are asked the reverse of it, like barium chloride reacts with sodium sulfate, what happens? There will be a reaction which is a double displacement reaction because barium chloride and sodium sulfate both are soluble salts. When they are soluble, they undergo ionization and exchange their ions and form barium sulfate and sodium chloride. Among these, which is the precipitate? You can be asked. Barium sulfate BaSO4 is insoluble salt, so it is a precipitate. Sodium chloride, as you know, it is a common salt and it is soluble. It is not a precipitate. Let us move to some other questions which I have chosen from the chapter number 2, acids, bases and salts. For remembering the reaction of acids with litmus, ABR is the abbreviation. Now, as per the abbreviation, acids turn blue, litmus red. You have to remember this. Hydrochloric acid turn blue, litmus red. Now, another abbreviation is BRB. BRB is base turning red, litmus blue. So like sodium hydroxide, calcium hydroxide, these will turn red, litmus blue. Now, next question is, what are the differences between the metallic oxide and the non-metallic oxides? Or it can be also asked in this way, why metallic oxides are called basic oxides and non-metallic oxides are called acidic oxides? Give the examples with equations. First of all, metallic oxides, for example, sodium oxide, when put into water, it forms the alkali, that is sodium hydroxide, which is a soluble base. And in this reaction, you can see that the sodium hydroxide is a base, and this base can be neutralized by using an acid. So, sodium hydroxide with an acidic oxide, that is non-metallic oxide, sulfur dioxide, again undergoes neutralization. Just like acid is neutralizing the base, the acidic oxide, that is SO3, is neutralizing the base, NaOH. So you can give these two sentences with the examples to prove that metallic oxides are the basic oxides and they form the bases. Now, in the same way, acids, if they are asked in this way, the non-metallic oxides dissolve in water to form the acids. So they are called as acidic oxides. And these acids are neutralized by the non-metallic oxides like sodium oxide to form the salt and water. It is also neutralization reaction. So the two sentences will help you to prove that non-metallic oxides are acids and metallic oxides are bases. Now let us see this, a very important question. I guess, how is anhydrous HCl gas prepared in the laboratory? The main process here is by mixing two different chemical compounds, like the concentrated sulfuric acid is added drop by drop using the dropper to the sodium chloride solution, which react to form the gas. It releases the gas, which is dry gas, that is hydrochloric acid. Generally it will be dry, but when there is moisture in the air, it can combine with the water to form the acid. So we use the the guard tube containing the calcium chloride, so that the calcium chloride absorbs the water from the HCl and you will get a dry HCl gas. which has a bleaching property. It removes the color of the cloth or the paper and makes it white in color. So bleaching property. If the hydrochloric acid is dissolved in water, hydrochloric acid dissolved in water forms the acidic solution of hydrochloric acid, and which turns the blue litmus red. Now let us see what is the common nature of acids and bases. Both acids and bases, they neutralize each other. I have given an example there. H2SO4 and NaCl gives HCl plus Na2SO4. There should be a correction here. H2SO4 plus NaOH gives H2O plus Na2SO4. Now they both neutralize each other. Now let us see what is common nature of acids and bases. Both acids and bases in dry condition, they do not exhibit their real nature, that is acidic nature or basic nature. Only when they are dissolved in water, they will show some test with the litmus paper, and they form the free ions actually to show the nature of themselves. So let us see what happens when the acids dissolve in water. HCl is taken, for example, dissolves in water and forms H3O hydronium ion and the chlorine ion. H3O is nothing but H plus ion itself. Because the H plus ion is unstable, it is reacting with the H2O to form H3O plus ion. Now let us see, acids contain more H plus ion, that is H3O plus ion itself. Now bases form always the hydroxyl ion. Let us see here, NaOH plus water gives Na plus ion and chlorine ion in the solution. So the common thing among them is they exhibit their real nature, acidic nature or basic nature, only when they dissolve in water, because they will form the respective ions in the solutions. Now in the next question, let us see, in the given figure, this figure may come for drawing also, but there may be another question, like tricky question. What happens to the glow of the bulb when water is added to the solution in this? Now when HCl is added to the water, it will form the free ions, that is H3O plus and Cl minus ion. But when we dilute the same solution by adding more and more water to it, the number of hydrogen ions or hydronium ions per unit volume decreases. So the number of ions when decreased, the conductivity of electricity also decreases. The solution becomes less conductor of electricity. So this will decrease the glow of bulb also, and the bulb looks dimmer and dimmer on adding water more and more. Now next question, give examples for the following. Let us see, acidic salts. Acidic salts are formed by reaction of strong acid with the weak base. For strong acids, we can take hydrochloric acid and sulfuric acid. Weak base, the best example is ammonium hydroxide. So the compound will be ammonium chloride or ammonium sulfate. They are very acidic salts. So when they are acidic, the pH value becomes 1, 2, 3, 4. Let us see basic salt. Basic salt is formed when strong base reacts with the weak acid. Strong bases are like calcium hydroxide and sodium hydroxide. Weak base is like carbonic acid or phosphoric acid. Here I have taken calcium hydroxide reacting with carbonic acid forms the calcium carbonate and sodium carbonate. So the pH value will be 12, 13, 14. That is the pH of the base. Now, neutral salts, how they are formed? When strong base reacts with the strong acid, the neutral salts are formed. Sodium chloride, potassium chloride, sodium sulfate, potassium sulfate, these are formed. See, sodium hydroxide when reacts with HCl forms the sodium chloride. In the same way, potassium hydroxide with HCl forms the potassium chloride. Just like that, sodium hydroxide reacts with sulfuric acid forms the sodium sulfate. So, strong acid reacts with strong base to form these neutral salts. The pH value will be equal to 7 or 6 to 8, which is a neutral value. Now, strong bases. Give the examples. Sodium hydroxide, calcium hydroxide, potassium hydroxide. These are all strong bases. They turn red litmus blue and they also turn the phenolphthalein to pink color, and their pH will be 12, 13, 14 because they have very least number of H plus ion concentration. The pH value will be highest. Now, strong acids. Examples are sulfuric acid, nitric acid and hydrochloric acid. Why they are called as strong acids? Because their pH value is 1, 2, 3, 4. That means they have highest concentration of H plus ion in their solution. Now let us see some of the differences between the metals and non-metals. We know that these are the physical differences what I have mentioned here. Metals are malleable, ductile, good conductors of heat and electricity. Generally they are solids and they have lustrousness, that is shining, and exhibit sonorous nature, means they exhibit a sound which is called as sonorous nature or metallic sound. Non-metals are exactly opposite, non-malleable, non-ductile, but they are brittle, means when we heat them they become powdered. Conductors of heat and electricity, they are very bad conductors of heat and electricity, and generally they are gases, mainly gases are there, very less number of solids are there. They do not have lustrousness and they also do not exhibit sonorous nature. When we hit them, they do not give the metallic sound. Now let us see one mark questions which can come like this. Name the following metals. The liquid metal is mercury, Hg. The liquid non-metal is bromine, Br. The metals which melt on palm are gallium and cesium. The non-metals which have lustrousness is iodine, which shines. The non-metal which is good conductor of electricity is gold. Next comes the silver, and also last comes the copper. Then the other metals will follow, like aluminum, iron, like that. The metals with very low density and very low melting point, and also they are soft and can be cut by using the knife, are lithium, sodium, potassium. Now, how do you say that aluminum oxide is an amphoteric oxide? Give the reaction. And aluminum oxide and zinc oxide are mainly the amphoteric oxides because they react both with acid and bases to form their salts. For example, Al2O3 with acid, that is HCl, if we take, there will be the formation of salt, aluminum chloride and water. With the base also, like NaOH plus Al2O3 will form sodium aluminate NaAl2O3 plus H2O. So this way the aluminum oxide will react with acid as well as base to form the salt and water. So please go through all the questions and the reactions related to the above first and second chapters and do the thorough revision to score good marks. Best of luck.